Okay, here's a fairly complicated exponential equation to solve in which we're going to use inverse functions. We're going to end up using inverse of e to the x, really, ln, which is log base e. And there are three steps to solving a complicated exponential equation. And this is an equation that we're going to solve for t, which is usually time. And this is actually a continuous compound interest problem. But this is the equation that you have to solve. And the first step is you isolate your exponential expression. And that's your exponential expression right there. We want that all alone. So I guess I better divide both sides by 200. And when I do that, I'll end up with 25 over 12 equals e to the 0.04 t, because 200 goes in there, cancel the two zeros, and you end up with, I'm sorry, 25 over 2, not 12, sorry. Okay, so I'm going to divide both sides by 200, and I end up with 25 over 2. Now my exponential expression is all by itself. Step 2, take the log of both sides. So I take the log of 25 over 2 equals the log, and we're lucky because these are going to be inverses of each other. We don't have to use property 3. Guess what? This cancels itself out, so we end up with the log. Oops. My chalk is not cooperating. Let me try it again. It's too damp or something. The log, and I hope you can read it here, of 25 over 2. I could actually write that as 12.5, couldn't I? And these cancel each other out, so I end up with 0.04 t. Now, I have to divide both sides. I have a linear equation. By the way, this is a number in your calculator. This is a log of 12.5, you know. You put it in your calculator, it's a number. This is a number. We divide both sides by 0.04, and we end up with a log of 25 over 2 divided by 0.04, and that's t. Now you have to put that in your calculator. You put log of 12.5 divided by 0.04, and it'll give you an estimate of what t is.